Good day, everyone. A very warm welcome to this session, which is one of those which is administered and sponsored by the South African Mathematics Foundation, in which we shall be looking at solving the problems that were set in the Olympiad papers. The one that we are going to look at today is the junior paper, the second round of the Mathematics Olympiad, which was set in 2024. So with those few words, we will go straight to the problems under discussion. Okay, the very first problem is okay. Fatima thinks of a positive integer, adds 3 to it, squares the result, and then subtracts 6. If she ends up with 43, then what number did she think of? All right, I think the best way to do this, there are other ways, but we will just say let the number be x. Let her number be x. And then we try to create an equation involving x using the information. It's a positive integer. She adds 3 to it. Let's add 3 to this and square the result. And then subtract 6. The answer is 43. Okay, so immediately if you take the numbers 6 to the other side, you'll have 43 plus 6 is 49. So some number squared is 49, so it has to be 7. And it's a positive integer, so x is equal to 4. You could have chosen -7 as well, but that's also a square root, but you're not going to land with a positive x in that. Okay, so that's the solution to the first problem. Let's get on to the next one. All right, I normally give all the problems will have the solutions, typed out solutions as well, and I will give you a small breather space to have a look at it. Okay, the next question, determine the value of x in degrees. You have several angles here, and you're asked to calculate x. Well, you can see they all add up to 360 degrees. So if you add all these angles which are present there, add, and so it's x plus 2x and so on. I'm not going to do the whole thing. Okay, but that is equal to 360 degrees. Because if you add up all these angles, it's an angle around this point. And this x plus goes all the way up to 8x. So that gives 36x is 360 degrees. The problem is to find x. So x is 10. Okay, so that takes care of problem number 2. Let's proceed with the third problem. Okay, so there's the full answer. Okay, let's go on to question 3. 5 consecutive numbers add up to 140, what is the smallest number? Okay, now here's an important fact. In any arithmetic progression, that means the sequence having a common difference. The sum of the numbers there's a very easy way of doing calculating the sum. It's equal to the middle times the number. The number of terms. Okay. You may not have a middle. You may have an even number of terms, so there's no middle. But then you can take the average of the two middles. All right? That will be the middle. Okay, so you got 5 consecutive numbers. So the middle number in the problem is 140 divided by 5, which is 28. And they're consecutive numbers. So the sequence must be in the middle here. And you got, so you must have 2 on either side. And you got 29 and 30 here. So the smallest, that's a question. The smallest is 26. Okay, you could have done it using symbols. Okay, I'll do that quickly. If you let x be the smallest, then the consecutive numbers will be x. The next one will be x plus 1, x plus 2. They're all consecutive. And there are 5 of them. And when you add up all these, you're going to get 140. So if you just keep adding all these, you got 5 x's here. And the numbers are 1 plus 2 plus 3 plus 4 is 10. So on the other side, you have 140 minus 10. So 5x is 130. So that gives you x is 26. So you could have done it that way as well to create an equation. Okay, so the next problem. So here I think I discussed both the methods. So that's the written solution. So let's get on to, okay, I'll give you the same useful fact which I gave earlier on. Okay, let's go to question 4. Determine the size of the angle marked x in degrees. Right, so you got a picture here. It's actually a quadrilateral. You see, you got 1, 2, 3, 4. There are 4 sides, but it's not a convex quadrilateral. Convex quadrilateral, all the angles are acute or obtuse. Now here you have one of the angles is reflex. You see, you can see this angle here. So it's called a concave quadrilateral. But the fact is, in any quadrilateral, the sum of the angles, internal angles, let's call that y, is 360 degrees. So y, we'll call that y, plus the other three angles, which is 80 plus 20 is 100, plus 130 degrees is 360. And so the internal, this is the internal angle. The sum of the internal angles of any quadrilateral is 360 degrees. So you see that y is 230. To bring it to the other side, and therefore y plus x is 360. And that's 130 degrees. Oh. I see they like the number 130, yeah? That's the third time 130 is appearing in this question. Okay, there is another way of doing this where you can join this one and produce it, and then add these two angles. This angle here is a sum of these two, because it's the exterior angle of a triangle, and this one here is also the sum of these two interior opposite. So when you add these two, you're going to add all these angles, right? So you'll see 30 plus 20 plus 50 is 130. So that's the answer. So this angle is actually the sum of those three. Okay, so that's the other way of doing it. And I think I discussed both the methods in the solution which I outlined. Oh, so yeah, I do discuss both the methods. All right, so we go down to the next problem, which says the following. Find the value of n if n is a whole number and 1 over n is greater than 1/3 but less than 3/4. All right, so your natural way of doing this will be to say that 1 over n lies between 1/3 and 3/4. And then try to calculate n there. N is a whole number. But we can see this thing straight away, because you see, for 1 over n is a whole number. So there are only two possibilities here. If 1/3 is smaller than 1 over n, so this n will have to be bigger than, will have to be smaller than 3. You see? So from here you can see n can be only 1 or 2. When you take these fractions, a half that's greater than 1/3, because you're dividing it up into 3 parts now. And if you divide it into 4 parts, each one is smaller, and 1/5 and so on. So this is always true. So if you've got 1/3 is smaller than 1 over n, so n can only be 1 or 2. It can't be 1, because 1 is not less than 3/4. So this is out. So therefore the answer is n equals 2. Yeah, so that's the best way of doing it. Or you can simplify. So you can cross multiply here, and you can straight away you can get n is less than 3 if you cross multiply. Yeah, and that comes back to n equals 1 or 2. Okay, so let's just get on with the next problem. These early problems are usually quite straightforward. So we don't need to spend too much of time over them. Also, yeah, I'll give you the answer very quickly. Okay, now let's have a look at problem question 6. It says here the diagram shows a large square. So you got this whole square here. And you're supposed to calculate the area of the shaded region. Okay, so I'm not going to see that, but they do say the large square has got area 81. So it means the area of a square is a side squared. So each side has to be 9. Okay. And they are divided up into identical small squares. So each one of these will have to be 3. Okay, here too you got 3 and 3, 3, 3. Because the side is 9 and the 9 is divided up to 3 equal parts. All right, so the area of the shaded region, this is a very funny region here. It's not easy to calculate this strange looking region here. It's not a rectangle or a triangle or anything like that. But what you notice is that the outside is very, very decent. They're all lovely right-angled triangles. So therefore, you exploit that fact and you simply say the shaded region plus the unshaded is equal to the whole area, which is 81. Right? It's given that the whole area is 81. Now, the unshaded is easy to calculate because unshaded is 3 triangles. The area of a triangle is easy. So the area of this triangle here is half base times height. So this area here is 27/2. And this area here is 9/2. The base times height is 9. And this area here is 6 times 6. So you got a 6 here, 6 here. But it's 6 times 6, which is 36, divided by 2. Okay. So if you add these unshaded, you got 29 plus 27 plus 9 is 36 over 2, that's 18. And here you got another 18, which is 36. And this is 9, which is 45. So the unshaded region is 45. So therefore the shaded will have to be 36. Right? It's 81 minus 5. So this is important that the part which is easy to calculate, you calculate that one and observe that these two areas add up to the area of the square. So the answer is 36. And as you can see, the worked out answer, which I worked out earlier. Oh, what happened here? Okay, I had 27/2. 27 plus 9 is 36. 18. What did I do? I rubbed it out. But it seems to me that I had to subtract 36. I'd had a 27/2. I had a 9/2. So 27 and 9 is 36. That gives you 18. And this area also was 36/2, which is 18. So the sum of the areas is 36, not 45. All right. Sorry about that. So the correct answer is 45 and not 36. I used 45 instead of 36. All right. Let's just get on. So one must be careful. I think there's a lesson here that even you, when you are doing your calculations to make sure your calculations are correct. Okay, now we're going to go on to question 7. A 2-meter long snake enters the long pipe. All right, so let's draw this. Oh, there's a pipe here. All right, so the snake here, it enters this thing. How many seconds? Oh, its speed is 0.2 meters per second. All right, so it goes into this pipe here. It travels at 0.2. How many seconds will it take for the snake to enter the pipe and then fully exit the pipe on the other side? I must be a little bit careful here. You have to see what distance it travels. It looks as if it travels for 2 meters. That's not true, though. Because let's look at the head of this snake. The head goes in here, and then it travels. The head goes right through here, comes to 2 meters, but it is not out of the pipe yet. It's still inside. And for the head, for it to be fully exit, they say it's fully exit the pipe on the other side, then it has to travel another 2 meters to get completely out. So it has to come out like that, and there's the head. Yeah. So it actually travels 4 meters. Right. So distance traveled is 4 meters. Traveled. As I said, you take the point, this, which is the head, and see how far that has traveled. If you think of the whole snake, then you might get confused. Distance traveled is 4 meters. Okay, so in 1 second, it covers 2 meters, 0.2, so it's 2/10 meters. And now you want to cover 2 meters, 4 meters. And you want to know how many seconds. So in each second, it covers 2/10. So it'll cover, you have to divide 4 by 2/10. Let's see how many 2/10ths are there in 4, right? Because each second, the second, another 2/10, and so on and so forth. And the division is, you invert this thing, and you get 4 times 10 divided by 2. So you divide fractions, and the answer is 20. And this is time, seconds. You must put down the units. Right? And how many seconds will it take? And the answer is 20. All right, so let's get on to the next problem, and let's take a quick look at, yeah, so the answer is 20. So we don't have a problem with that. And now let's get on to the next problem, which is question 8. Question 8 says, so this is the number line. So A is 32. It's a number on the number line, and 104. C is at 104. What number is located at B? But they tell you that the ratio of these two lengths is 5:3. Now, with ratios, one important fact is you don't say that AB is equal to 5 and BC is equal to 3. See, it's 5/3. And this fraction, the numerator need not be 5. It could be 10/6. It's the same thing. Or 15/9. See? 20/12. So if you got a number which is, unless it's simplified completely, then you can say that AB is 5 and BC is. But they don't tell you that. So the So, the numerator is not 5, but it will be 5x. 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 5 times something. 5 times 2, 5 times 3. And here it's 3x. So in other words, the full length is from 32 to 104, and that is 72. So 8 times x is 72. So x is 9. So if x is 9, so this will have to be 45. So that's the length. From here to here, the distance is 45. So the point B will have to be 32 plus 45, which is 77. Starts off with 32, you see? 77. So that's the number which is located in B. And if you look carefully, you'll see 77. If you subtract it from 104, you get 23, 27, which is 9 times 3, 27. Okay, and 45 is to 27 is the same as, to cancel the 9s, you get 5 over 3. All right, so that is how you do that problem. And we now get on to, oh, there it is. So we got the right answer. Okay, so we're doing the question 9 now. Okay. The average of 10 numbers is 15 if the 4 largest numbers are 20, 22, 23, and 25. What is the average of the 6 smallest numbers? Okay, these average sums, the most important thing is regarding average is that average multiplied by the number of numbers is equal to the sum of the numbers. Very important fact. Because how do you calculate the average? What you do is, to calculate the average, you add everything up, we call that sum, and divide by how many numbers you've got, so n numbers, right? So that is how you calculate the average. So if you rewrite this thing here, multiply on both sides by n, then you'll have a times n equals s. That's exactly what I'm saying. Average times the number of numbers is equal to the sum of the numbers. Right. So if the average of 10 numbers is 15, then the sum of the 10 numbers is the average multiplied by the number, which is 150. Okay, the sum of all the numbers. The sum of the 4 numbers, the largest numbers, right? We can see it's 4. So just add up all these things here. You get 45, 50, 75. 45, 70, 90. Yeah, is 90. Sum of 4 of those numbers is 90. Now they ask you for the average of the 6 smallest numbers. So we know we can work out what the 6 remaining numbers is. It has to be 60. Because all 10 is 150. And therefore the average, if the sum of those numbers is 60, then the average will have to be 60 divided by 6, which is 10. All right, so that is the solution to this problem. It's a simple application of averages, and let's just check to see. There it is. So you can see the answer is 10. as it is said there. Okay, let's look at question 10 now. A bus completed 3 trips. On the first trip, it was 30% full. On his second trip, it was 90% full. And on his third trip, it was 60% full. If in total 72 different bus tickets were used, what is the capacity of the bus? Oh, okay. That's interesting. So the capacity means how many people could the bus hold. All right. So let's give a name to the capacity. Let X be the capacity of the bus. It is the number of people that the bus can actually carry. If X is 100, that means the bus has got 100 seats in it. That's what it means. Right. So in the first trip, it is 30% full. So in other words, 30% is 3/10. So that means the number of people on the first trip will be 3/10 times X. 30% of X. I'm going to write this as 3x/10. Right. And likewise, second trip, the 30% is 90. So it's 9x/10. And the third trip, it's 60%. So that's 6x/10. 6/10. And the total number in the number of tickets issued will be the total number of people who came to the bus, which is 3x/10 plus 9x/10 plus 6x/10. 3 plus 9 is 12, 18, so it's 18x/10. But we know that the total number of tickets issued was 72, so you have an equation. So this is the number of tickets issued when you calculate in one way, but we were told that it's 72. So then you can solve for X, yeah? Multiply by 10, 720, and 720 divided by 18 is 40. So that's the answer to the question, because we said X is the capacity. So we need to calculate X. We just did. The answer is 40. All right. So we get on to the. Oh no. Okay. Before that, let me just see. Okay. So X is 40. All right. So this is the same answer that I got when I worked it out some time ago. So let's get on to the next problem. We go to question 11. Determine the size of the unknown angle in degrees. Oh, you got a kind of a lightning flash here. But these two lines are parallel, and you got 120 degrees here. So, and you needed to know what this angle here is. Now these are not alternate angles because you got a jagged one here. If they are alternate angles, you need to have a straight line that connects this to this. So how do you calculate this? All right. Now the way to do this is to draw a construction. I'm going to draw. I got a parallel line. I'm going to draw a third line going through that one, like that, which is parallel to these two given lines. Okay, so having drawn that, why did we do that? Because now we can use So all these three lines are parallel. Now you see I can go to, because these are parallel lines, this must be 60, right? Because co-interior angles in parallel lines add up to, or supplementary, add up to 60. And here, okay, now this is a straight line. So you got 60 plus 90 is 150. So this angle has to be 30 degrees, right? So you got 30 degrees. Now this angle here, which we're looking for, is actually equal to this, because these are corresponding angles. There's your Z here. So this is your question mark. But now in this thing here, the question mark, you see you got a triangle here, and this one of the sides is extended. So this is the exterior angle of this triangle, and its theorem in geometry. So the exterior angle is the sum of the interior opposite angles. So you've got those two add up to give you question mark. So the answer to the problem is 100 degrees. Okay, now you see, interesting. You actually have to draw another line to solve this problem. As it stands, it couldn't, would not have been able to solve it. I'm sure there are many other constructions. Like, for instance, I can extend this line and extend this line so that they meet, and so you got transversals. In other words, you got straight lines which join one to the other. So you could have done some other constructions. It will be nice for you to try some other construction and see whether you can come to the same answer. Okay, or you could draw the line parallel from here. All right. Let's just look at these drawings. And oh, so I drew the line parallel at the bottom. Okay, so this was the other way of doing it. And eventually I get to the same answer, as you can see. I drew my parallel line at that point. See, I drew my parallel line at this point here. But you could have drawn a line parallel. Then you could have also come to an answer. Okay, both of them will lead to an answer. And let's get on to the next problem. Problem number 12. It says that given the following pattern, in which row will 2024 lie? So let's just analyze this. So you got 1, you got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you got 3 here, and you got 5 numbers here, and you got 7 numbers here. So the next one will have 9 numbers, next one will have 11 numbers. And you want to know in which row 2024 lies. Now that's a very big number. Let's try to see whether there's anything special about this. But if you look carefully, you'll see the last numbers are squares. So this is 1 squared, this last number. Here, the last number is 2 squared in the second row. In the third row, the last number is 3 squared. In the fourth row, the last number is 4 squared. So now 2024, so you want to know what the nearest square to 2024 is. So it'll have to be in that row, right? Now, fortunately, we are now living in 2025, and by now you should know that 2025 is a square. It's one of the few square numbers in years. So this is 45 squared. That's the year in which we are. This question was set last year. So maybe at that time, the learners didn't really know that the next year was a perfect square. But anyway, that tells you if that is, so that is the 45th row, and 2024 would have been just before that. So the answer is 45th. All right, so Okay, then let's just check to see whether we did the same thing here. All right, there it is. It's the same. It's exactly the same thing.